Hello, in this video I just want to introduce Raoult's law and its applications. So Raoult's law is used when you have gas and liquid systems that are in equilibrium, and this is the equation that we'll be working with. And to introduce all of these and show how they relate, let's get started and define these. So lowercase p sub a is the partial pressure of component A, and our other P, the capital P right here, is going to be our system pressure, or the total pressure. It's going to be the sum of all the pressure components. Okay, and this should look a little familiar if you watch the videos on the Antoine equation. This is our vapor pressure of A. This is the vapor pressure of the pure component A at a certain temperature, and remember the units. Temperature is degrees Celsius, the pressure is millimeters of mercury, and all we're going to be doing is for that is using the Antoine equation with the constants A, B, and C. Okay, and then there's these two other variables right here. We have x sub A and y sub A, and both of these are mole fractions. Alright, and as I said earlier, Raoult's law deals with systems that have gas and liquids in equilibrium. So if you thought that these correspond to gas and liquid, then you're right. So x sub A is the liquid mole fraction of component A, and for y sub A, that's going to be the vapor mole fraction of component A. Alright, and it's also really important to know how all of these values are related. So I said this earlier, but I'll write it down, that the total pressure is just going to be the sum of all the partial pressures, depending on how many different components you have. Okay, and if you want to solve for the mole fractions, y sub A or x sub A, that's just going to be the partial pressure of that component over the total pressure, and for the mole fraction in the liquid phase, that's going to be the partial pressure of that component over the vapor pressure of that component. And one other important thing to note, it might seem obvious, but that the sum of all the mole fractions is going to be 1, and this is for both x and y. So the mole fraction component 1 plus component 2 plus so on will have to equal 1, and the same goes for y. Alright, so I hope you have a decent understanding of the variables in Raoult's law, and soon in a future video we'll do a practice problem. Alright, thanks for watching.